Hello students, welcome to Concept Clarity, and this is your favorite physics channel. And I am Navito here. We are going to cover about electricity. We are going to solve NCERT unsolved problem number 1 to 6. So let's move ahead. Let's start quickly. Let's see the first problem number 1. What is stated in problem number 1? We are given a wire. Wire has resistance R. This is the original resistance of the wire. And then this wire is cut into 5 equal parts. Then each of these part is connected in parallel, and the equivalent resistance upon connecting it in parallel, after connecting it in parallel, that means all the left and the right hand of the cut wires are holding each other's hand. Left hand is holding all the others left hand, and all the right hand is holding all the other right hand, and the equivalent resistance is given as R dash of this parallel combination. So now we are asked, what is the ratio of the original resistance versus the equivalent resistance of the parallel combination? So let's tackle this. So we are going to make use of resistivity formula. Here it is clear that the wire is same. That means cross-sectional area is same. Material is also same. That means rho and area A will remain same. Original length L. If we assume L is the original length of resistance, original length of the wire, then the new length of the wire will become L by 5 for each of the part. So let us see the resistance, how it's represented. If you remember, good. If you don't remember, here it comes on the screen. R is equal to rho L by A. So now what we do? These are the things which you already know. We have already seen this. Resistance of the original wire is also rho L by A, because L is the original length, right? It is given by rho L by A. So now after cutting it into 5 parts, what will happen to the length? Length will become L by 5. Length has become L by 5. As you see here, length has become L by 5. So next, now what is the resistance of this cut part? Resistance of the cut part, the length in the original formula, this original formula length will be replaced by L by 5, right? Length will be replaced by L by 5. So what will happen? The new resistance of the cut part is rho L by 5 upon area. Cross-sectional area doesn't change, and rho also doesn't change. So this is the resistance of the cut part, not the equivalent resistance of the parallel combination. Now each of these R part is going to connected into parallel. So for parallel combination, we know that equivalent resistance is taken as the reciprocal of all the resistors, right? So we're going to take the reciprocal of R by 5, each part. So we'll get 5 by 5 into 1 by R part. This is what is shown here. So now what do we do? What do we do now? Now replace it, right? R part is already known. R part is R by 5. So we can put this R by 5 into R part. So now what we get? We put R by 5 into R part. This is what we got. So now upon rearranging the entire formula, the 5 will come in the numerator, will get multiplied by the numerical 5, that is the numerator, will get 25 by R. So next, what will happen? 1 by R dash is equal to 25 by R. So now upon rearranging this, what is asked? R by R dash is asked. We are asked R by R dash. This is what we have been asked. So now what we'll do? We'll rearrange this. We'll rearrange this equation. We'll put R in the numerator and R dash in the denominator. So if we have to do that, then 25 will go in the numerator. So the answer will be, answer of the ratio will be 25. So this is your final answer. Final answer. Sahi jawab. आप बन गए करोड़पति. Let's move on to the next problem. दूसरा सवाल आपके स्क्रीन पे. Which of the following terms does not represent electric power in the circuits? So now you have to get your step by step tackling or step by step strategy right. So first you have to see what is given. What is given we have to know, then finally what is asked. And then from what is given, we have to identify the correct equation for whatever we have learned. So now here what is given? It is said about electrical power. Electrical power, we know power is equal to VI. Power is equal to voltage into current. So now then we also know Ohm's law also. Using Ohm's law, we can represent voltage and current in terms of resistance, because in your answer, there is resistance involved. And because there is resistance involved in your answers, we are going to make use of Ohm's law. So step 1, power is equal to voltage into current. I always look to everybody on this side, on the right side. Like I should be looking at you on the on the camera. Yeah, I'll get used to it eventually. So using Ohm's law, V is equal to current into resistance. We can now write power in different forms. First, the initial form is VI only. So the VI form is the right option. VI is the right option. But we are asked the incorrect option. So now what we do? We use Ohm's law to replace V first. Let us replace V with IR. So you'll get I square R. That means I square R is also the right answer. Next, we substitute now. I'll rub this part here. Okay. Now if you rearrange the Ohm's law, equation for Ohm's law, V is equal to IR, we can also write it as I is equal to V upon R. This is what is written here, right? I is equal to V upon R. So now what we do? We put this I in the original equation for power, that is VI. So we will get V square by R. We got now V square by R. And V square by R is also the right option. So that means the only incorrect option remaining now is I R square. So this is your final answer, right? Option C is correct first. Then second we saw I square R is correct. That means option A is correct. Then we saw that V square R is correct. That means option D is also correct. Option B is incorrect. We clear the screen? और अभी जाते हैं आगे तीसरे सवाल पे, कौन बनेगा करोड़पति रे बाबा। और तीसरे सवाल आपके स्क्रीन पे आ रहा है। Third problem. Here we have been given about an electric bulb. Electric bulb is rated 220 volts and 100 watts power. Voltage is given and power is given. So now when voltage is given and power is given, we have to remember that we can use power is equal to VI, plus we can use Ohm's law also, because terms are given which we can use both these equations. So now it is given that when it is operated on 110 volts, the power consumed will be how much? So now we know what formula we can use here. So what is given? Rated values of the bulb is given. Rated voltage is 220 volts. 220 volts is the rated voltage. 220 volts is the rated voltage. This is the rated voltage. Then what is given? The rated power is given. Rated power is 100 watts. Then what we have been given? Now been given that it is also given that it is operated on 110 volt. What will be the power consumed? So we have to find the resistance of the bulb by using the rated power and voltage, right? We can use this equation for power by using a combination of power is equal to VI and Ohm's law of V is equal to IR. Upon replacing I, we'll get V square by R, right? So we can use this equation to find R, resistance. So now we rearrange this. We can write R is equal to, R will move here and power will come to the denominator. That means we'll get V square by P. V square by power you'll get. So now we can replace the values. Upon replacing the values, you'll get 484 is the resistance. Is the resistance of the bulb by using the rated power and rated voltage. Now we use this resistance to find the power consumed. on the new operated voltage. Operated voltage at 110. Bulb is now connected to 110 volts. Power consumed will be V square by R, the new power. And upon solving this, you will get 25 watts. 25 watts is the right answer. So let's move ahead to our next problem. चौथा सवाल आपके स्क्रीन पे. सॉल्व करो अभी. You have seen almost 3 problems. Now you can solve this problem. Try it yourself. Take some time and try it yourself. I will count 1 to 5. If I give you 5 minutes, then you will do fast forward. Right? 1, 2, 3, 4, 5. What is given here? 2 conducting wires. That means 2 wires here. This time 2 wires. Same material. Very important. Same material means rho is same. Right? Resistivity is same. Of equal length. Length is also same. Equal diameter means area is also same. Are first connected in series. What is given? First it is connected in series. And then it is connected in parallel. Across the same potential difference. Potential difference is same. What is it? Same. What is the ratio of the heat produced in series and parallel? That means it is asking ratio of the heat produced. Right? So we know the heat ka formula is already clear to you. Joule's heating formula clear to you. Recollect. So what we need to do? Heat produced in a resistor in given time T is given by V square. That means voltage ka square upon resistance into time. V square voltage ka square divided by resistance into time. This is the heat produced ka formula. Heat produced formula. Okay. Now resistance of each wire. Will now deduce the resistance of each wire. What is given? Both wires are same material. As I said earlier, both wires are same material. Equal length and equal diameter also. Let's assume the resistance of the wire is R. Okay. So now for series combination, what will happen? For series combination, equal resistance will be addition of R. That means it will be 2R. Right? So you got here 2R. Series combination resistance is 2R. Next, heat produced will be now, we have to take this series ka equivalent resistance. We have to take series ka equivalent resistance and replace it under with heat ka equation. So what you'll get? What we do, I'll put it here once again. We take this 2R and put it in R. So finally we will get the new equation is, for series combination, the heat is V square by 2R into time. Next, now for parallel combination is reciprocal of the resistance, right? So you'll get R parallel will be R by 2, which is clear, right? R parallel will be resistance by 2. Now what will be the heat produced? Now again you replace this R parallel in the same equation to get for heat produced in the parallel combination. So heat produced in the parallel combination is, after replacing, you will get 2V square by R. You will get 2V square by R into time after replacing the values. And finally, now what we need? We need the ratio of series by parallel, right? So we got series, we got parallel. Now we have to take the ratio. It's heat produced by series, heat produced by parallel. We replace all the values, right? We replace all the values. I'll just show it here. For series, this is the value. It will come here on the numerator. And for parallel, this is the value. It will come in the denominator. After cancelling out whatever common value, this V square will cancel with V square. This 2 will cancel. R will cancel. T will cancel. Right? And 2 will come in the denominator. This 2 will come in the denominator. It will multiply and you will get 1 by 4. So option number C is the right answer. This option number C here is the right answer. So hope you have understood this. Fourth problem we have solved. Now we'll go ahead and solve Now we'll come to fifth problem. So how is the voltmeter connected in a circuit to measure the potential difference between 2 points? Always, if you want to measure the voltage, we need to connect it in parallel. So we see for a series combination of resistor, the voltmeter is connected in parallel. Even for a parallel combination resistance, if you want to measure the voltage, it is still connected in parallel. That means if it is parallel combination, means voltage ka left and right hand will join the left and right hand of all the resistors or all the wires in the particular circuit. So this was an easy question. So we'll move ahead to the next question. See the final question. Problem number 6. Final question. Finally, you will meet your 3 crore ka objective, 3 crore ka goal. Kaun banega crorepati ka goal? So now, what is given in this problem? Please read it out and try to solve it once. I'll count 1, 2. Pause this video and try to solve. Pause the video and try to solve. Okay. Let's solve now. Pay attention. Copper wire, diameter 0.5 millimeter. Remember, it's given in millimeter. Okay. So you might have to convert it into meter, or resistivity you have to convert it to millimeter. Better to convert into meters. Resistivity is given as 1.6 into 10 raised to power of -8. What will be the length of this wire to make its resistance 10 ohm? So here we make use of resistivity ka formula, right? And then another part to the question, which I forgot to read out. How much does the resistance change if the diameter is double? That means two questions are asked here. The first question is basically what will be the length to make the resistance 10 ohm? And then if the diameter is double, what will be the change in resistance? So what is given here? Diameter of the copper wire is given. Diameter of copper wire is given as 0.5 mm. This we convert into meter. So we get it 0.5 into 10 raised to power of -3 meters. Right? Next, radius is given as 0.25 into 10 raised to power of -3 meters. Radius is not given. Diameter is given. Diameter was given. So diameter we divide into 2. Right? Diameter is given. Right? 0.5 by 2 you will get. Am I right? Yeah. Diameter is given. This is 0.5. 0.5 divided by 2 you will get 0.25 into 10 raised to power of -3 meters. Resistivity already given. Resistivity is given here, right? This is resistivity. Next, required resistance is 10 ohm. So now we use the magical resistivity formula. Chalo, let's use resistivity. Cross-sectional area is, you have to calculate because R is given, radius is given. So we'll get the cross-sectional area. Once you get cross-sectional area, we use the resistance ka formula, which is R is equal to rho L by A. So now we want the length, right? So we rearrange the formula with respect to length. We rearrange the formula with respect to length. We will get resistance into area divided by resistivity, which is rho. So now you put all the values. What is given? What you need? R you need as 10 ohms, right? R you need as 10 ohms. 10 ohms here. For this value of resistance, you need to find the length. And then area is basically 1.96 into 10 raised to power of -7. This value you put in A, 1.6 into 10 raised to power of -7 divided by rho. And rho is given here, which is 1.6 into 10 raised to power of -8. So upon calculating this, you'll get length as 122.5 meters. The length of the wire should be 122.5 meters long. okay, for that given data. Now, what is the effect of doubling the diameter? That means diameter is double. Original diameter, if it was 0.5, the area, if the diameter is double, means the radius will double. And the radius is double means area will become proportional to 4, right? 2 square. Correct? Next. Now we use the formula R is equal to rho LA. We replace, area increases 4 times. So resistance becomes 1/4, right? So it is clear here. For the new resistance will be 10 by 4, which will become then finally 2.5 ohms. How much will the resistance change? It will change. The new resistance will be 2.5 ohm. This is the new resistance. And with this, we conclude. If you have any questions on this problem, you try to solve this at home. If you have questions about when radius doubles, how does the area become 2 square? Please recollect. This is part of maths. You will get it. You try to solve it once. And if you are still not able to get it, please put your comment. Okay, we'll try to solve it together. Okay, until then, the final answer. Sahi jawab. A tougher question for you. Clear my screen. And in our next session, we'll take another 5 to 6 problems, right, from NCERT only. So if you have liked this video, if you have liked the problem solving step-by-step method, please like, subscribe, and share it to your friends also, so that they are able to tackle the NCERT solution. We'll also solve, apart from NCERT, we will take problems from different other books, different other textbooks. We'll try to solve them in this particular channel. So thank you.